In this section, we're going to look at the unit circle. The unit circle is basically a circle of radius 1 centered at the origin with the equation x squared plus y squared equals 0. So here's an example of our unit circle. And again, radius meaning 1 just says that the distance from the center out to any point is 1 unit. To find points on the unit circle, we just need to remember that all points must satisfy the equation x squared plus y squared equaling 1. So, to find the points that have x coordinate 3/5, what we're going to do, 3/5 squared plus y squared equal to 1. Squaring 3/5, we get 9/25 plus y squared equals 1. Subtracting the 9/5, we get y squared equals 16/25, or y equals plus or minus 4/5. So here we end up with 2 points with the x coordinate 3/5 that lie on the unit circle. 3/5 5/5 and 3/5 negative 4/5. In some cases, we may want to find points in a particular quadrant that has a particular coordinate. So here we want to find the points that have y coordinate 1/3 that are in quadrant 2. So we're going to start out the same way. We'll plug in 1/3 for the y. X squared plus 1/3 squared will equal 1. So x squared plus 1/9 will equal 1. X squared equals 8/9, or x equals plus or minus 2√2/3. Now because we're in quadrant 2, we know that the x coordinates in quadrant 2 are negative, so our coordinate that we're looking for is negative 2√2/3, comma 1/3. Terminal points are something else that we're going to be asked to look for in dealing with the unit circle. So a point starting at 1, 0, moving a distance t along the unit circle, ends at a terminal point P of xy. If t moves counterclockwise, then t is positive. If t moves clockwise, then it is negative. Okay? So here is a positive t, here's a negative t. Recall that the circumference of a circle is found by c equaling 2 pi r, where r is the radius of the circle. So the unit circle has circumference 2 pi. Again, r is just 1. And so we can break up our unit circle into quadrants, starting with t equals 0 being the point at 1, 0. Going in the counterclockwise fashion, we get the positive t values, 1/4 of the 2 pi, or pi over 2, half of the 2 pi, or pi, 3/4 of the 2 pi, which is 3 pi over 2, and then 1 full revolution, which will give us the circumference of 2 pi. And obviously we can go the other direction, and we get the negatives of those. Some other values to keep in mind here are t equaling pi over 6, pi over 4, and pi over 3. These are going to be some of the nice angles that we're going to look at periodically throughout the trig section of this course. So one of the things we're going to be asking you to do in this course is to find terminal points determined by a real number t. And so to do this, we are looking for the x and the y coordinates at the endpoint of a particular t value. And so again, if we think of the circumference being 2 pi, we can break that up into pieces of the unit circle. So for this first one, we're looking at t equal 5 pi over 6. So we're looking at an angle in the second quadrant. Length is 5 pi over 6. And we want to find the x and the y coordinates for that. So what we can notice, and this is where knowing the table on page 372 will come in handy. This looks at some of your basic terminal points, pi over 3, pi over 4, and pi over 6. We can use that information for that third quadrant. Okay? So for t equaling 5 pi over 6, we know that our x coordinate is going to be negative and the y coordinate is going to be positive. And so here we can see that at pi over 6, x equals root 3 over 2, and y equals 1/2. But we're not quite at pi over 6. We're 5 times that away in the second quadrant, which means that the distance between that value and the x-axis is pi over 6. So here, our terminal point, the x has to be negative in order to be in the second quadrant, and the y value has to be positive. For t equal negative pi over 3, again we're going to use the same values for pi over 3, except now we're going in the negative direction. So now we're looking in the fourth quadrant. So our t value here at pi over 3, x will be 1/2 and y will equal root 3 over 2. Since we're in the fourth quadrant, both our x is positive, but our y is going to be negative. So our terminal point becomes 1/2 negative root 3 over 2. Again, we're looking at a negative angle. This one happens to be on the y-axis. Okay. So again, if we're looking at the unit circle, we can actually find this point easily. Our terminal point is going to be 0, -1. Since our x value has to be 0 to be on the y-axis, and since we went in the negative direction, we're at 0, -1. For t equals 7 pi over 6, we're looking at an angle in the third quadrant. Okay, so this is a positive angle. Again, if we look at the value between the distance between that angle and the x-axis, again there's a value of pi over 6 there, because we know at the x-axis on that side we're at a value of pi. So here we know again at x equal pi over, or at pi over 6, we know x is root 3 over 2 and y is 1/2. So here, because we're in the third quadrant, both x and y are negative. So we have that our terminal point is going to be negative root 3 over 2, -1/2. Now one of the concepts that we're using to find these values is what we're going to call a reference number. So if t is any real number, then the reference number t bar is the shortest distance along the unit circle between the terminal point determined by t and the x-axis. So just like what we've looked at in some of these last examples. So if we want to find some of these reference numbers, we're going to look at where they end up and what the distance between the x-axis and that terminal value is. So for this first one, t equal 2 pi over 3, we can see that 2 pi over 3 is in the second quadrant. So to find the reference number, we're looking for the distance between that angle and the x-axis. Well again, in this case, we know that pi is the value to the left, so we're basically looking for the distance between pi and 2 pi over 3. So we can find that by subtracting, and we see that our reference number is pi over 3. Okay. For t equal negative pi over 6, we want to do the same thing. So negative pi over 6 is going to be in the fourth quadrant. It's that negative angle. So to find the reference, again we're looking for the distance between that and the x-axis. Okay. So in this case, we're starting at 0 and subtracting the negative pi over 6, and that will give us the distance. So our reference number is pi over 6. Notice, as we mentioned, the reference numbers are distances, so these are always going to be turn out to be positive values. Okay. Let's look at a couple more. So let's say t equals 5 pi over 4. So 5 pi over 4 is going to land in the third quadrant. Again, measuring to the x-axis, we're looking at the value closest to pi, so the distance between 5 pi over 4 and pi. So we're going to subtract those two values, and again, because we want it to be positive, we'll subtract the pi from the 5 pi over 4, and we can see that our value turns out to be pi over 4. So that's our reference number. Now, not all of your t values are going to be between 0 and 2 pi, but we can still find the reference numbers the same way. For these, what we're going to do is we are going to look at the particular revolution that the t falls in, meaning subtract off multiples of 2 pi, and then look at the closest distance to the x-axis. So for t equal 31 pi over 6, okay, the first thing to notice is if I look at 30 pi over 6, that's basically 5 pi. So we're looking at the third revolution of the unit circle. So we've gone around 2 full times. In the third revolution, we're going to pass up 5 pi and land at 31 pi over 6. Okay. So again, the closest distance to the x-axis takes 31 pi over 6 minus the 5 pi, which will get a common denominator of 6. So 31 pi minus the 30 pi over 6, which gives us a reference angle of pi over 6. And lastly, let's look at one more. Let's look at a negative angle. Again, multiple revolutions. So here again, if we look, negative 41 pi over 4, again, the first thing we can see is 41 pi over 4. We're going to go a couple revolutions and make it a negative 40 pi, which would be 10 revolutions. So a lot of revolutions the unit circle, again in the negative direction. We get negative 10 pi, and the distance between that and the x-axis, we're going to take negative 41 pi over 4 from the negative 10 pi. Again, because we're looking at negative angles, we're going to go from the x-axis out to the angle. Again, we'll get a common denominator, and we can see that our reference angle is pi over 4. Many of the concepts we have talked about in this video, dealing with the unit circle, are just some of the basics that we're going to need in order to talk a little bit more about trigonometry. Trigonometry is some of the stuff that we'll get into in the next section. Again, we just need some of the ideas that we've mentioned here to be able to evaluate trig functions.